All right, mathematicians, get ready for some transformations. Well, that was my attempt at sound effects for a transformer. Anyway, we'll start with translation, section 4.1. And our essential question, how can you translate a figure in a coordinate plane? So mathematicians will be able to perform translations, compositions, and solve real-life problems involving compositions. All right, let's get started with our first key point, vectors. Here's a picture of a vector. They're kind of fun. It's a quantity that has both direction and magnitude, in other words, size. And it's represented in a coordinate plane by an arrow drawn from one point to another. In this case, from point P to point Q. I see an arrow. The initial point is your starting point. In this case, point P is our starting point or initial point. Our terminal point is the ending point, in this case, Q. Our horizontal component is the movement plus, which is right, or negative, which is left, and it's our A movement as indicated on our grid. Our vertical component is the movement up, which is positive, or down, which is negative, and that's our B value, as you can see in the grid. Naming a vector, you use the initial and terminating point with what looks like a half ray. So it looks kind of funny. It's just half of a ray. And then the two letters underneath it. And then we have component form, which look like funny looking parentheses, but they're pointy parentheses. And then you have your A, the horizontal component, comma, vertical component. So let's just practice with example 1, identifying the vector components of the picture in the diagram. So name the vector and then write its component form. So we start at the initial point, which is J, and we figure out the horizontal component, which is 3, positive 3, and then the vertical component, which looks like it is 1, 2, 3, 4. So positive 4. So with our pointed parentheses, we have the 3, 4. And then the name of it is a vector JK with the funny looking ray, half ray above the two letters. All right, let's move on to key point number 2, which is translations. This entire unit's all about transformations. Well, transformations are the function that moves or changes a figure in some way to produce a new figure. So the first one we're going to learn about in this unit is translations. And that's a transformation that moves every point of a figure the same distance in the same direction. In other words, slide. Our implied statement states that translation implies our component form A, comma B, or this coordinate form, which is x plus or minus a, comma, y plus or minus b. And we have our images, which are new figures, and pre-images, which are the original figures. And then we have prime notation. It's how we can indicate and distinguish the pre-image from the image. So this is super important. If my pre-image is named triangle ABC and it maps onto a new image, I need some kind of symbol to indicate what the new image is. So we use these little prime symbols, which look like apostrophes. So I can say A prime, B prime, C prime. So a single prime symbol means single prime. It means one transformation. And then if I see a double prime, then that means I have two transformations. And I can also name figures with different letters. So the pre-image could be one grouping of letters and it maps onto a different set of letters, as long as your notation indicates what is the pre-image and what is the image. So the pre-image is always listed first, maps onto, with this arrow, the new image. And then we will be learning 4 types of transformations. Translations, in other words, your slide. Reflections, in other words, a flip. Rotations, in other words, your turn. dilations, in other words, enlargement or reduction. So first, starting with a translation, we can add some value of A to X values, and then some value B to our Y coordinates. And notice that we maintain size and shape. All right, so let's take a look at example 2, where we will translate a figure using a vector. You're going to need graph paper. So the vertices of triangle ABC, so go ahead and graph the vertices. So you can pause the video here and graph. Then you want to translate triangle ABC using the vector 5, -1. So your images should look literally just like these, where I can see triangle ABC, the pre-image, translated 5 to the right, down 1. So every vertex translates 5 down, 5 to the right, 1 down. And make sure you remember your prime notation for the new image. Super important so that we can distinguish between the pre-image and the new image. And at this point, you can use either the component form or coordinate notation form. All right, so let's take this image that we're given and write a rule. So you want to start with the pre-image, and our pre-image in this case is A, the blue image. A that doesn't have the prime symbol is your pre-image, so A, B, and C. And we can pick any vertex and decide how much it moved left, right, up, down. So it looks like it's moving up 1 and left 4. And that's true for all vertices, up 1 and left 4. So our vector rule, or component form, would be the pointed looking parentheses and then -4, 1. Or you can do coordinate notation, which is xy mapped onto x - 4, y + 1. All right, next, let's take a look at graphing quadrilateral ABCD with the following vertices. So -1, 2, B's at -1, 5, C's at 4, 6, and D's at 4, 2. And its image after the translation, x + 3, y - 1. So that means every x value will be adding 1. So let's take a look at this. So if the rule is that we're going to add 3 to every x value and subtract 1 from every y value, so A is going to map onto 2, 1. So A prime will be located at 2, 1. B, add 3 to -1, you get 2. Subtract 1 from 5 and you get 4. So B prime, the image is at 2, 4. C prime then will be at 7, 5. Adding 3 to the x, so adding 3 to 4 gets you 7. Subtracting 1 from 6 gets you 5. For D, adding 3 to 4 gets you 7. Subtracting 1 from 2 gets you 1. So you can do it by hand, just using your, plugging in the x and y coordinates to use the rule, or you can also graph it and translate 3 to the right and down 1. All right, next let's take a look at how we perform compositions. Before we do that, let's identify some vocabulary. The first one is rigid motion, which is also known as isometry. This is where we preserve length and angle measure. And then a composition of transformations is when we have 2 or more transformations that are combined to form a single transformation. All right, so our first postulate is our translation postulate, which simply means a rigid motion. And we just mentioned that a rigid motion preserves length and angle measure. So when I say rigid motion, I'm saying that the length and angle measures all stay the same as I move around in a coordinate plane. So our implied is translation implies rigid motion, in other words, isometry. And then our our theorem, composition theorem, is 2 or more rigid motions is a rigid motion. So our implied composition of 2 plus transformations implies rigid motion. Okay, so let's take a look at examples of each of these postulate and theorem. So for the postulate, when we say it's a rigid motion, in other words, isometry, all the lengths and from one image, from the pre-image to the image, are the same. So the length from D to E is equal to the length from D prime to E prime. And I can see the markings on my picture. So I have matching congruent marks and congruent angles. So length and angle measures maintained and are preserved from one position to a new position. In other words, a transformation. And since we're practicing translations in this first section, it's true for all translations. And then composition theory or theorem states that if I have more than one, no matter how many different transformations occur, it's still going to maintain length and measure. So here's a great example. Here's the original, so the pre-image, PQ. It translates to P prime, Q prime, and then it translates again to P double prime, Q double prime. So we consider this final image the composition of two different translations. All right, so let's take a look at an example where we will perform a composition. You'll need graph paper once again. It's a graph segment RS with endpoints at -8, 5 and -6, 8. And then its image after the composition. So here's an example of a composition. I have first translation. I'm going to add 5, subtract 2. My second translation from the first will be that I subtract 4 and then subtract 2. And you need to go in order. So let's take a look. So I will add 5 to the -8. So for this first translation, I will add 5 to the -8, resulting in a -3. I will subtract 2 from the 5, resulting in 3. So R prime is located at -3, 3. S is going to be located at -1, 6 with the same transformations. Then your second translation is to take what you got as your result from the first translation. Those are the values you use for X and Y for the next movement. So now I'm going to subtract 4 from R prime's X value, which is -3. So this -3 plugs in here for X, minus 4, resulting in -7. Then this 3 plugs in for Y, subtract 2, resulting in 1. Do the same thing for S. So this will result, so take these values, S prime, plug in for X and Y. For S double prime, I end up at -5, 4. So if I do all these movements on a grid, this is what it should result to look like. Make sure you label and include labels with the prime symbols, very, very important. If you don't have the prime symbols, then it's hard to know which is the pre-image and then which ones are the image. And if there's more than one transformation, in other words, a composition, then it's really hard to tell which ones are the new images and in what order they go in. All right, our last example, you're designing a favicon for a golf website. In an image editing program, you move the red rectangle 2 units left and 3 units down. Then you move the red rectangle 1 unit right and 1 unit up. Rewrite the composition as a single translation. So here we're just practicing with this idea of a video game where we can move pieces around on a grid. So we just want to take the 2 translations. So the first one would be that we subtracted 2, so we moved 2 left, and then, so that's a -2, and then we went down 3. So A prime would end up at this location. Well, then we take that translation, and that becomes the start of the next translation, and I'm wanting to add 1 to the previous. So I'm adding 1 to the -2, and then I'm adding 1 to the -3. So if we simplify all of that, your single translation rule for the composition should result to an X minus 1, Y minus 2. All right, we're flying with progress now, so bring any clarifying questions as we begin this new unit, and we'll practice in class. See you then.